Hi friends, I'm Uday Kandpal and I welcome you all to a fresh new lecture on NCERT Class 6 Notes on Geography by Uday Kandpal. The name of the chapter is The Earth in the Solar System. So let's talk about the Earth. Earth is the third planet from the Sun and the only astronomical object known to harbor life. About 29.2% of the Earth's surface is land consisting of continents and islands. The remaining 70.8% is covered with water, mostly by oceans, seas, gulfs and other salt water bodies, but also by lakes, rivers and other fresh water which together constitute the hydrosphere. Much of the Earth's polar regions are covered with ice, and Earth's outer layer is divided into several rigid tectonic plates that migrate across the surface over many millions of years, while its interior remains active with a solid iron inner core, a liquid outer core, and generates Earth's magnetic field and a convective mantle that drives plate tectonics. Earth's atmosphere consists mostly of nitrogen and oxygen. More solar energy is received by tropical regions than the polar regions, and is redistributed by atmospheric and ocean circulation, greenhouse gases, and also play an important role in regulating the surface temperature. A region's climate is not only determined by latitude but also by elevation and proximity to the moderating oceans, among other factors. Several weather, such as tropical cyclones, thunderstorms, and heat waves, occur in the most areas that have large impact on life. Earth's gravity interacts with other objects in space, especially the Moon, which is in Earth's total only natural satellite. Earth orbits around the Sun in about 365.25 days. Earth's axis of rotation is tilted with respect to its orbital plane, producing seasons on Earth. The gravitational interaction between Earth and the Moon causes tides, stabilizes Earth's orientation on its axis, and gradually slows its rotation. Earth is the densest part in the solar system and the largest and the most massive of the four rocky planets. According to radiometric dating, estimation, and other evidence, Earth formed over 4.5 billion years ago. With the first billion years of Earth's history, life appeared in the ocean and began to affect the Earth's atmosphere and surface, leading to the proliferation of the anaerobic and later the aerobic organisms. Some geological evidence indicates that life may have arisen as early as 4.1 billion years ago. Since then, the combination of Earth's distance from the Sun, physical properties, and geological history have allowed life to evolve and thrive. In the history of life on Earth, the biodiversity has gone through long periods of expansion, occasionally punctuated by mass extinctions. Over 99% of all species that ever lived on Earth are extinct. Almost 8 billion humans live on Earth and depend on the biosphere and natural resources for their survival. Human beings increasing impact Earth's surface, hydrology, atmospheric processes, and other life. So let's talk about the Moon. The Earth has a moon. So the Moon is Earth's only natural satellite. At about 1/4 of the diameter of Earth, comparable to the width of Australia, it is the largest natural satellite in the solar system relative to the size of the planet, and the fifth largest satellite in the solar system overall, larger than any dwarf planet, orbiting Earth at the average distance of 3,84,400 kilometers. That's about 2,38,900 miles, or about 30 times Earth's diameter. Its gravitational influence slightly lengthens Earth's day and the main driver of Earth's tide. The Moon is classified as planetary mass object and differentiated rocky body, and lacks any significant atmosphere, hydrosphere, magnetic field. Its surface gravity is about 1/6 of the Earth's, 0.16454 G. The Jupiter's moon Io is the only satellite in the solar system known to have a higher surface gravity and density. The Moon's orbit around the Earth has a sidereal period of 27.3 days and a synodic period of 29.5 days. The synodic period derives its lunar phases, which form the basis of the month from the lunar calendar. The Moon is tidally locked to Earth, which means the length of the full rotation of the Moon on its own axis is the same as the synodic period, resulting in its same side, always facing Earth. That said, 59% of the total lunar surface can be seen from the Earth through its shifts in perspective, its libration. The near side of Moon is marked by dark volcanic maria, or the seas, which fills the space between the bright ancient crustal highlands and prominent impact craters. The lunar surface is relatively non-reflective, and reflectance just slightly brighter than that of the worn asphalt. However, because it reflects the direct sunlight, it's contrasted by relatively dark sky and a large apparent size when viewed from the Earth. The Moon is the brightest celestial body or object in the Earth's sky after the Sun. The Moon's apparent size is nearly the same as that of the Sun, allowing it to cover the Sun's almost completely during a total solar eclipse. The first man-made object to reach the moon was Soviet Union's Luna 2 uncrewed spacecraft in 1959. This was followed by the first successful soft landing by Luna 9 in 1966. The only human lunar mission to date have been those of the United States NASA Apollo program, which conducted the first crewed lunar orbiting mission with Apollo 8 in 1968. Beginning with Apollo 11, 6 human landings took place between 1969 and 1972. These and later uncrewed missions returned lunar rocks, which have been used to develop a detailed geological understanding of the moon's origins, internal structure, and subsequent history. And the most widely accepted origin explanation posits that the moon formed about 4.51 billion years ago, not long after Earth, out of the discovered debris from a giant impact between the planet and hypothesized Mars-sized body called Theia. Both the moon's natural prominence in the earthly sky and its regular cycle of phases as seen from the Earth have provided cultural references and influences for human societies and cultures throughout the history. Such cultural influences can be found in the language, calendar system, art, and mythology. Now let's talk about some festivals on Purnima. But before we will discuss what is Purnima and Amavas. Purnima is the word for full moon in Sanskrit. The day of Purnima is the day in each month when the full moon occurs and marks the division in each month between two lunar fortnights, the Pakshas, the Krishna Paksha and the Shukla Paksha. And the moon is aligned exactly in the straight line called Syzygy, and the sun and earth. The full moon is considered the third of the four primary phases of the moon. The other three phases are new moon, first quarter moon, and the third quarter moon, or the gibbous moon and the crescent moon. The crescent moon and the gibbous moon. The full moon shows 100% illumination, causes high tides, and can concur with lunar eclipses. Amavasya or Sanskrit Amavasya is the lunar phase of the no moon in Sanskrit. Indian calendars use 30 lunar phases called tithis in India. The dark moon tithi is when the moon is within 12 degrees of angular distance between the sun and moon before conjunction, or the Syzygy, and the new moon tithi called the Pratipada or Prathama is the 12 angular degrees after the Syzygy. Amavasya is often translated as new moon since there is no standard term for the moon before conjunction in English. Let's talk about some festivals that occur on Purnima. The Kartik Purnima is celebrated on the full moon day at the month of Kartik. It's also called Tripura Purnima. The Shravan Purnima is the full moon day in Shravan. This day has a number of different names. Haigreav Jayanti is also celebrated on Shravan Purnima. It is also known as the Narali Purnima. The Vat Purnima is celebrated on full moon day on the month of Jesht. Women pray for their husband by tying threads around a banyan tree on this day. It honors Savitri, the legendary wife of Satyavan who escaped death for her husband's life. It is chosen day for the worshipping of Yamdev. Guru Purnima. Devotees after puja to their guru on the full moon day of Ashad. This is well known as Vyas Purnima, after the birthday of celebrated author of Mahabharata, who is declared as the guru of all in the Shiv Puran. Sharad Purnima or the Kojagiri Purnima, the autumn harvest festival on the full moon day of Ashwin. Buddha Purnima, the day of birth, enlightenment and passing away of Gautam Buddha. On full moon day of the Vaishak, Kurma Jayanti is also celebrated on that day. Dol Purnima, Holi, Falgun Purnima, the spring festival of colors in the Hinduism, Buddhism, Jainism, the full moon day in Falgun. Dattatreya Jayanti is celebrated on the full moon day after the month of Margshir. Hanuman Jayanti is celebrated on the full moon of the lunar month Chaitra. However, this is celebrated on different days in the different states. While Odisha celebrates the Vaishak Jayanti, Andhra Pradesh celebrates the Vaishak Shukla Paksha Dashami. Kerala celebrates it in previous month Margshira Amavasya, coinciding with the Mool Nakshatra. Chaitra Purnima is chosen day for donation of rice to please Sri Chandra Dev, moon god. Shakambhari Purnima is celebrated on full moon day of the month of Paush. Madhu Purnima is celebrated on the full moon day of the month of Bhadra. On this day, Uma Maheshwar Vrat as well as the Shakra Vrat, where Indra is worshipped for the children and well-being. The Satyanarayan Puja Vrat is observed on the all full moon days. So let's talk about the celestial bodies or the astronomical objects now. In astronomy, an astronomical object or celestial object is a naturally occurring physical entity, association or structure that exists on the observable universe. In the astronomy, the term object and the body are used interchangeably. However, an astronomical body or a celestial body is single tightly bound contiguous entity, while the astronomical or celestial object is a complex, less cohesively bound structure which may consist of multiple bodies or even other objects with substructures. Example of astronomical objects include the planetary system, the star clusters, the nebulae, the galaxy. The asteroids, moons, planets and stars are astronomical bodies. A comet may be identified as both body and object. It is body when referring to the frozen nucleus of ice and dust, and an object when describing the entire comet with its diffuse, and tail. So let's talk about the solar system. The solar system is a gravitationally bound system of the sun and the objects that orbit it, either directly or indirectly. Of the objects that orbit the sun directly, the largest are the 8 planets, with the remainder being smaller planets, the dwarf planets, and the small dwarf system bodies, solar system bodies. Of the objects that orbit sun indirectly, the natural satellites too are larger than the smallest planet, Mercury. The solar system formed 4.6 billion years ago from the gravitational collapse of the giant interstellar molecular cloud. The vast majority of the solar system's mass is in the Sun, with the majority of the remaining mass contained in the Jupiter. The 4 small inner planets, Mercury, Venus, Earth, Mars, are terrestrial planets, while being primarily composed of the rock and metal. The 4 outer planets are giant planets, being substantially more massive than the terrestrials. The 2 largest planets, Jupiter and Saturn, are gas giants, while they are composed mainly of hydrogen and helium. And the 2 outermost planets, Uranus, Neptune, and ice giants, being composed mostly of the substances with relatively high melting points compared with the hydrogen and helium, called volatiles, such as water, ammonia, and methane. All the 8 planets have almost circular orbits that lie within the nearly flat disk called ecliptic. The solar system also contains smaller objects. The asteroid belt, which lies between the orbits of Mars and Jupiter, mostly contains objects composed like that of the terrestrial planets of the rock and metal. Beyond the Neptune's orbit lie the QPR Belt and the scattered disk, which are populations of trans-Neptunian objects composed mostly of ice, and beyond them a newly discovered population of cygnoids. Within these populations, some objects are large enough to have rounded under own gravity, though there is a considerable debate as to how many there will prove to be. Such objects are categorized as dwarf planets. The only certain dwarf planet is Pluto, with another trans-Neptunian object, Eris, expected to be in the asteroid series at least close to being a dwarf planet. In addition, these 2 regions, various small body populations including comets, centaurs, interplanetary dust clouds, freely travel between these regions. 6 of the planets and the 6 largest possible dwarf planets and many of the smaller bodies are orbited by natural satellites, usually termed as moons, after the moon. Each of the outer planets is encircled by the planetary rings of dust and other small objects. The solar wind, a stream of charged particles flowing outwards from the sun, creates a bubble-like region in the interstellar medium known as the heliosphere. The heliopause is the point where pressure from the solar wind is equal to the opposing pressure of the interstellar medium. It extends out to the edge of the scattered disk. The Oort cloud, which is thought to be the source of the long-period comets, may also exist at a distance roughly 1,000 times further than the heliosphere. The solar system is located in the Orion Arm, 26,000 light years from the center of the Milky Way galaxy. So let's talk about the structure and the composition of the solar system. The principal component of the solar system is the Sun, which is a G2 main sequence star that contains 99.86% of the system's known mass and dominates gravitationally. The Sun's 4 largest orbiting bodies, the giant planets, account for 99% of the remaining mass, with the Jupiter and Saturn together comprising more than 90%. The remaining objects of the solar system, including the 4 terrestrial planets, the dwarf planets, the moons, the asteroids, come together comprise less than 0.002% of the solar system's total mass. Most large objects in the orbit around the Sun lie near the plane of the Earth's orbit, known as ecliptic. The planets are very close to the ecliptic, whereas comets and QPR belts are objects are frequently at significant greater angles to it. As a result, the formation of the solar system, planets and other most objects orbit the Sun in the same direction that the Sun is rotating, counterclockwise as viewed from the Earth's north pole. The exceptions, such as the Halley's Comet, most of the larger moons orbit the planets in this prograde direction, with Triton being the largest retrograde exception, and most larger objects rotate themselves in the same direction, Venus being a notable retrograde exception. The overall structure of the charted regions of the solar system consists of the Sun, the 4 relatively small inner planets surrounded by a belt of rocky asteroids, 4 giant planets surrounded by a QPR belt of mostly icy objects. Astronomers sometimes informally divide the structure into separate regions. The inner solar system includes the 4 terrestrial planets and the asteroid belt. The outer solar system is beyond the asteroids, including the 4 giant planets. Since the discovery of QPR belt, the outermost parts of the solar system are considered a distinct region consisting of objects beyond Neptune. Most of the planets in the solar system have secondary systems of their own, being orbited by the planetary objects called natural satellites or moons, 2 of which, the Titan and Ganymede, are larger than planet Mercury. The 4 giant planets have planetary rings, thin bands of the tiny particles that orbit them in unison. Most of the larger natural satellites are in synchronous rotation, with one face permanently turned towards the parent. The Kepler's law of planetary motion describes the orbits of the sun around objects around the sun. Following Kepler's law, each object travels an ellipse with the sun at one focus. So objects closer to the sun with the semi-major axis travel more quickly because they are more affected by the sun's gravity. On the elliptical orbit, a body's distance from the sun varies over the course of its year. Body's closest approach to the sun is called the perihelion, while its most distant point from the sun is called the aphelion. The orbits of the planets are nearly circular, but many comets, asteroids, and Kuiper Belts objects follow high elliptical orbits. The position of the bodies in the solar system can be predicted using numerical models. Although Sun dominates the system by mass, it accounts for about only 2% of the angular momentum. The planets dominated by Jupiter account for most of the rest of the angular momentum due to the combination of their mass, orbit distance, and from the Sun, with the possible significant contribution from comets. The system, which comprises nearly all the matter in the solar system, is composed of roughly 98% of hydrogen and helium, and Jupiter and Saturn, which comprise nearly all the remaining matter and are primarily composed of hydrogen and helium. A composition gradient exists in the solar system, which is created by the heat and light pressure from the sun. Those objects closer to the sun which are being affected by heat and light pressure are composed of elements with the high melting points. Objects farther than the sun are composed largely of materials with lower melting points. The boundary of the solar system beyond which those volatile substances could condense is called as the frost line, and it lies roughly at 5 astronomical units from the sun. The objects of the inner solar system are composed mostly of rock, and the collective name for compound with the high melting points such as silicates, iron, nickel that remain solid under the almost conditions in the protoplanetary nebula. Jupiter and Saturn are composed mainly of gases. Astronomical terms for materials which are extremely low melting points and high vapor pressure such as hydrogen, helium, and neon, which are always in the gaseous phase in the nebula. Ices like water, methane, ammonia, hydrogen sulfide, and carbon dioxide have melting points up to few hundred kelvins. They can be found in ices, liquids, or gases in the various places in solar system, whereas in the nebula they are either in the solid or the gaseous phase. Icy substance comprise the majority of satellites of the giant planets, as well as most Uranus and Neptune. They are so-called ice giants, and numerous small objects that lie beyond the Neptune's orbit. Together, the gases in ice are referred to as volatiles. Now let's talk about the sun. The sun in the solar system star. The sun is the solar system star and by far the most massive component. Its large mass 3,32,900 Earth masses, which comprise of 99.86% of all the mass in the solar system, produces the temperature and densities in its core high enough to sustain the nuclear fusion of the hydrogen into helium, making it a main sequence star. This releases an enormous amount of energy, mostly radiated into space as electromagnetic radiation, peaking in the visible light. The sun is a G2 type main sequence star. Hotter main sequence stars are more luminous. The sun's temperature is intermediate between the hottest stars and that of the coolest stars. Stars brighter than and hotter than the sun are rare, whereas substantially dimmer and cooler stars, known as red dwarf, make 85% of the stars in the Milky Way. The sun is a population 1 star and has a higher abundance of elements heavier than hydrogen and helium. Metals in the astronomical parlance than the older population 2 stars. Elements heavier than the hydrogen and helium were formed in the course of ancient and exploring stars, so the first generation of stars had to die before the universe could be enriched with these atoms. The oldest stars contain few metals, whereas the stars born later to have more. This high metallicity is thought to have been crucial in the sun's development of planetary system because planets formed from the accretion of metals. So there is an interplanetary medium between the sun and the solar system object. The vast majority of solar system consists of a near vacuum known as an interplanetary medium. Although along with the light, the sun radiates a continuous stream of charged particles known as a plasma known as a solar wind. The stream of particles spread outwards at roughly 1.5 million kilometers per hour, creating a tenuous atmosphere that permeates the interplanetary medium out to at least 100 AU. Activity on the sun's surface, such as solar flares and the coronal mass ejection, disturbs the heliosphere, creating the space weather and causing the geomagnetic storms. The largest structure being the heliosphere in the heliospheric current sheet, a spiral form created by the actions of the sun's rotating magnetic field on the interplanetary medium. Earth's magnetic field stops its atmosphere from being stripped away by the solar wind. Venus and Mars do not have a magnetic field, and as a result the solar wind is causing the atmosphere to gradually bleed away into space. A coronal mass ejection and similar events follow a magnetic field and a huge quantity of material from the surface to the sun. The interaction of its magnetic field and materials with the Earth's magnetic field funnels charged particles into Earth's upper atmosphere, where its interactions causes aurorae seen near the magnetic poles. The heliosphere and the planetary magnetic fields for those planets that have them partially shields the solar system from the high energy interstellar particles called cosmic rays. The density of the cosmic rays of the interstellar medium and the strength of the sun's magnetic field change the very long time scales, so the level of cosmic ray penetration in the solar system varies, though by how much it is unknown. The interplanetary medium is the home to at least two disk-like regions of comet dust that first the zodiacal dust clouds lie in the inner solar system and causes the zodiacal light. It was likely informed by the collision within the 10 astronomical belt brought on the gravitational interactions with the planets. Second dust cloud extends from the 10 AU and 40 AU and was probably created by similar collisions within the QPR Belt. Now let's talk about the inner solar system. The four terrestrial or the inner solar system have dense rocky composition, few or no moons and no ring systems. They are composed largely of refractory minerals and silicates which form the crust, and metals such as iron and nickel which form the cores. Three of the four inner planets, Venus, Earth and Mars, have atmospheres substantial enough to generate weather, all the impact craters and tectonic surface features such as rift valleys and volcanoes. The term inner planet should not be confused with the inferior planet, which designates those planets that are closer to the Sun than Earth is Mercury and Venus. The Mercury, or about 0.4 astronomical unit from the Sun, is the closest planet to the Sun and average all 7 other planets. The smallest planet in the solar system with a 0.055 m+. The Mercury has no natural satellites besides impact craters. Its known geological features are lobed ridges or roots that were probably produced by the period of the contraction nearly in its history. Mercury's very tenuous atmosphere consists of atoms blasted off its surface by solar winds. Its relatively large iron core and thin mantle have not yet been adequately explained. Hypotheses include that its outer layers are stripped off by giant impact, or that by it prevented from actually fully accreting by the young sun's energy. Venus, about 0.7 astronomical unit from the Sun, is close in size to Earth, and like Earth, it's about 0.815 m+, and like Earth has a silicate mantle around an iron core, a substantial atmosphere and evidence of internal geological activity. It is much drier than the Earth and its atmosphere is 90 times as dense. Venus has no natural satellite. It is the hottest planet with a surface temperature over 462 degrees or 400 degrees Celsius approx, most of likely due to the amount of greenhouse gas in the atmosphere. No definitive evidence of current geological activity has been detected on Venus, but it has no magnetic field that would prevent depletion of its substantial atmosphere, which suggests that its no atmosphere is being replenished by volcanic eruptions. Earth's 1 AU from the Sun is the largest and densest of the 9 planets, also only one known to have current geological activity and the only place where life is known to exist. Its liquid hydrosphere is unique among the terrestrial planets, and it's the only planet where the plate tectonics have been observed. Earth's atmosphere is radically different from those of the other planets, having been altered by the presence of life to contain 21% free oxygen. It has one natural satellite, the Moon, the only large satellite of the terrestrial planet in the solar system. Mars 1.5 AU from the Sun is smaller than Earth and atmosphere, about 0.107 mass of Earth. It has an atmosphere of mostly carbon dioxide and the surface pressure of 6.1 millibars, roughly about 0.6% of that of the Earth. Its surface peppered with the vast volcanoes such as Olympus Mons and the rift valleys such as the Valle Marineris show geological activity that may have persisted until as recently as 2.2 million years ago. Its red color comes from the iron oxide in its soil. Mars has two tiny natural satellites, the Deimos and the Phobos, thought to be either captured asteroids or ejected debris from a massive impact early in the Mars's history. So then there is an asteroid belt. Asteroids, except for the largest series, are classified as small solar system bodies, and are composed mainly of the refractory rocky and metallic minerals with some ice. They range from a few meters to 100 kilometers in size. Asteroids smaller than 1 meter are usually called meteoroids and micrometeoroids, grain size depending upon somewhat arbitrary definitions. The asteroid belt occupies the orbit between Mars and Jupiter between 2.3 and 3.3 AU from the Sun. It is thought to be the remnant of the solar system's formation that failed to coalesce because of the gravitational interference of Jupiter. The asteroid belt contains tens of thousands, possibly millions of objects over 1 kilometer in diameter. Despite this, the total mass of the asteroid belt is unlikely to be more than a 1,000th of that of Earth. The asteroid belt is largely sparsely populated, where spacecraft routinely pass through without incident. Ceres is the largest asteroid protoplanet and a dwarf planet. It has a high diameter, slightly under 1,000 km, and a mass large enough for its own gravity to pull its spherical shape. Ceres was considered to be a planet when it was discovered in 1801 and was reclassified to an asteroid in 1850s as further observation revealed additional asteroids. It was classified as a dwarf planet in 2006 when the definition of planet was created. Let's talk about the asteroid groups. The asteroid in the asteroid belts are divided into asteroid groups and families based on their orbital characteristics. Asteroid moons are asteroids that orbit the larger asteroids. They are not as clearly as distinguished as the planetary moons, sometimes being almost as large as their partners. The asteroid belt are also main belt comets, which may have been a source of Earth's water. Jupiter trojans are located in the Jupiter, the L4 or the L5 points, gravitationally stable regions leading and trailing planets in the orbit. The term trojan is also used for small bodies in the other planetary or satellite Lagrange point. Hilda asteroids are in the 2-3 resonance with Jupiter, that is, they go around the Sun 3 times for every 2 orbit Jupiter orbits. The inner solar system also contains the near-Earth asteroids, many of which cross the orbits of the inner planet. Some of them are potentially hazardous objects. So let's talk about the outer solar system. The 4 outer planets, or the giant planets, sometimes called as Jovian planets, collectively make up 99% of the mass known to the orbit the Sun. Jupiter and Saturn are together more than 400 times the mass of Earth and consist overwhelmingly of the gases hydrogen and helium, hence the designation as gas giants. Uranus and Neptune are far less massive, less than 20% mass of the Earth each, and are composed primarily of ice. For these reasons, some astronomers suggest that they belong to their own category of ice giants. All four ice giants have rings, although the Saturn's ring system is easily observed from Earth. The term superior planet designates planets outside the Earth's orbit and thus includes both the outer planets and Mars. Jupiter 5.2 AU at 318 times the mass of Earth is 2.5 times the mass of all other planets put together. It is composed largely of hydrogen and helium. Jupiter's strong internal heat creates a semi-permanent features in its atmosphere, such as the cloud bands and the Great Red Spot. Jupiter has 79 known satellites. The 4 largest, Ganymede, Callisto, Io, and Europa, show similarities to terrestrial planets such as the volcanism and internal heating. Ganymede, the largest satellite in the solar system, is larger than Mercury. Saturn, 9.5 astronomical units, distinguished as by its extensive ring systems, have several similarities to Jupiter, such as atmospheric composition and magnetosphere. Although the Saturn has 60% of the Jupiter's volume, it's less than a third as massive at 95 mass of Sun. Saturn is the planet of the solar system that is less dense than water. The rings of Saturn are made up of small ice and rock particles. Saturn has 82 confirmed satellites composed largely of ice. These of the satellites, Titan and Enceladus, shows signs of geological activity. Titan, the second largest moon in the solar system, is larger than the Mercury and the only satellite in the solar system with a substantial atmosphere. Uranus 19.2 astronomical units at the 14 times mass of the Earth, is the lightest of the outer planets. Uniquely among all the planets, it orbits the Sun on its side. Its axial tilt is over 90 degrees to the ecliptic. It has much colder core than the other giant planets and radiates very little heat to the space. Uranus has 27 known satellites, the largest one being the Titania, the Oberon, the Umbriel, the Ariel, and the Miranda. The Neptune 30.1 AU, through slightly smaller than Universe, is massive, 17 times the mass of Earth, and hence more dense. It radiates more internal heat but not as much as Saturn or Jupiter. Neptune has 14 known satellites. The largest, Triton, is geologically active and with geysers of liquid nitrogen. Triton is the only largest satellite with a retrograde orbit. Neptune is accompanied in its orbit by several minor planets named as Neptune trojans that are in 1:1 resonance with it. Comets are small solar system bodies, typically only a few kilometers across, composed largely of volatile ices. They have highly eccentric orbits, generally a perihelion with the orbits of the inner planets and an aphelion far than Pluto. When a comet enters the inner solar system, its proximity to the Sun causes its icy surface to sublimate and ionize, creating a coma, a long tail of gas, and a dust almost visible to the naked eye. Short period comets have orbits lasting less than 200 years. The long period comets have orbits lasting thousands of years. Short periods comets are thought to be originating the QPR belt, whereas the long period comets such as Hale-Bopp are thought to originate in the ORT cloud. Many comet groups such as the Creuse sun gazers form from the breakup of single parent. Some comets with the hyperbolic orbits may originate outside the solar system, but determining the precise orbit is difficult. Old comets whose volatiles have been mostly driven out by the solar warming are often categorized as asteroids. Let's talk about the QPR belt. The QPR belt is a great ring of debris similar to the asteroid belt, but consisting mainly of objects composed primarily of ice. It is extended between 30 and 50 astronomical units from the sun, though it is estimated to contain anything from dozens to thousands of dwarf planets. It is composed mainly of the solar system bodies. Many of the large QPR belts objects such as Quasar, Varun and Orcus may prove to be dwarf planets. With further data, they are estimated to be over 1 lakh QPR belt objects with diameter greater than 50 kilometers. But the total mass of the QPR belt is thought only to be about a tenth or even a hundredth of the mass of the Earth. Many QPR belt objects have multiple satellites, and most have orbites that take them outside the plane of the ecliptic. The QPR belt can be roughly divided into classical belt and the resonances. The resonances are orbit linked to that of Neptune, twice for every 3 Neptune orbits or 1 for every 2. The first resonance begins with the orbit of Neptune itself. The classical belt consists of objects having no resonance with Neptune and extend from roughly 39.4 astronomical unit to 47.7 astronomical unit. Members of the classical QPR belt are known as the QPR after the first of their kind to be discovered 15,760 Albion or 15760 Albion, which previously had the provisional designation of 1992 QB1 and thus are still nearly primordial low eccentricity orbits. Now let's talk about the Pluto and Charon. The dwarf planet Pluto, with an average size orbit of 39 astronomical unit, is the largest known object in the QPR belt. When discovered in 1930, it was considered to be the 9th planet. This changed in 2006 with the adoption of formal definition of planet. Pluto has relatively eccentric orbit inclined 17 degrees to the ecliptic plane and ranging from 29.7 astronomical unit from the Sun at perihelion to 49.5 astronomical unit at aphelion. Pluto has a 3:2 resonance with Neptune, meaning that Pluto orbits twice around the Sun for every 3 Neptunian orbits. QPR belt objects whose orbit share this resonance is called as Plutinos. Charon, the largest Pluto's moon, is sometimes described as a binary system with Pluto as the two bodies of orbit a base center of gravity above the surfaces. Beyond Charon, 4 much smaller moons, Styx, Nix, Kerberos and Hydra, orbit within the system. Makemake and Haumea. Makemake, 45.79 astronomical unit average, although smaller than Pluto, is the largest known object in the classical QPR belt, that is the QPR belt object not in a confirmed resonance with Neptune. Makemake is the brightest object in the QPR belt after Pluto. It was assigned a naming committee under the expectation that it would prove to be a dwarf planet in 2008. Its orbit is far more inclined than Pluto's at 29 degrees. Haumea, or 43.13 astronomical unit average, is in the orbit similar to the Makemake, except that its temporary 7:12 orbital resonance with Neptune. It was named under the same expectation that it would prove to be a dwarf planet, though subsequent observations have indicated that it may not be a dwarf planet after all. So thank you for listening to my lecture. Hope you liked it. Hope you learn a lot about the geography for the competitive exam as well. Thank you. Have a nice day. Bye bye.